All right, the next talk in the developer track this afternoon is Evan, and he'll be presenting productionizing Spark and the Spark REST job server. Let's welcome Evan.
Hello? All right, cool. Yeah, hope everyone's enjoying Amsterdam. This said, I haven't been to the city in 10 years, and it's a fantastic city, lots of great food. I'm staying by the canals, just having a lot of fun. So just out of curiosity, how many folks are using Spark in production? Awesome. This is a lot of people. Let's get a show of hands. How many people are running Spark on Yarn? A lot of people. How many people are running Spark standalone? Few folks. And how many people are trying out the Mesos stuff? All right, cool. Awesome. That's a good use of good survey. So a little bit about myself. My name is Evan Chan. I'm an engineer at TupleJump. Many of you probably haven't heard of us, but if you want to, follow me or find my GitHub repos, whatever, its information is here. I've been using Spark since 0.8. How many folks were using Spark at 1.0 or earlier? All right. So, yeah, it's pretty funny, like how amazing the Spark community has grown. When I was using 0.8, it was kind of like, this is really cool technology, but no one's using it. But we wanted to use it anyway, and now everyone's using Spark. So it's pretty amazing how much this has grown, and seeing how many of you guys are here. It's very exciting. Do we still need to use the mic? Hello? OK, awesome. And I've also been using Cassandra for a long time. I'm a DataStax Cassandra MVP. And I maintain the Spark job server that I'll be talking about. And a little bit about my employers, TupleJump. We are a big data technology leader, and we provide solutions as well as we are development partners. So we have a couple of pretty interesting projects. One of them is my latest project, Failover. This is a Spark-based analytics database in the mode of Vertica. And it's especially tuned towards time series and event data. I'll be talking about it tonight at the Cassandra user group meetup, which is tonight at the ING headquarters. If any of you guys are interested in coming, there will be an all-star lineup, including Patrick McFadden and a couple of other DataStax folks and myself. And we also have some other interesting projects, including SnackFS, which is HDFS on Cassandra, as well as an open Stargate, which is an open source Lucene index for Cassandra. And we basically provide different big data consulting and development partnership. So we have a lot of experience with Spark and Cassandra, so you can reach out to me if you guys are interested. So deploying Spark. There are so many choices in the Spark world. There is Yarn, Mesos, Standalone. You can deploy it with the distribution. There's different environments that you can distribute it. You can in your data center, in your cloud. There's a lot of things to think about. What are your choices in sort of in terms of deploying? I understand a lot of you guys are probably using it in production already, but there's probably a lot more folks here that are considering how to deploy Spark. So hopefully this will be useful to a lot of you guys. We'll try to cover a lot of ground to cover, but we'll try to cover all of it. All right. So I think that most of you are probably familiar with the basic terminology, but just in case you're not, Spark has every Spark application is also called a driver program. And in it, it starts a Spark context. The Spark context is a cluster manager that actually talks to the different environments. There's a cluster manager for Yarn, there's a cluster manager for Mesos, and one for Standalone. And within each worker, there's actually technically only one worker process per node, but you can have different executors. And the executors have caches, and within the executors, tasks are run. I think everyone is pretty much, no one has problems with the basic terminology, right? Yes, everyone's pretty good? OK. So what all of the cluster managers have in common, which is actually pretty nice, that Spark guys have put in a lot of effort the last few years to put the last few releases to put them all in, is that every clustering mode, you can run the Spark driver app in what is called cluster mode, which means that your applications, either they can run locally on the box that you launch it, or they can run in the cluster. And so cluster mode means the application is running in the cluster. And one of the benefits of running it in the cluster mode is that you can have it restart your application automatically upon failure. And they all have UIs to examine the state of your workers and apps. However, all the UIs are different. Standalone mode is the easiest clustering mode to deploy. You can deploy it using mixed-distribution.sh, and you can simply start the master and start the slaves with actually one command line. After you deploy, I always test it with something simple like the Spark shell, which is the easiest thing to get running, just to make sure they can connect, run a few simple commands, queries, whatever, and make sure that it's up and running. In standalone mode, there's an XA mode for the master. It used to be that for a long time there was no XA, but now if you have Zookeeper, it can be used to elect a master, and you can have multiple masters. One thing about the standalone mode is that you have to dedicate the whole cluster to Spark. That could be a good or bad thing depending on your use case. But if you're a big company trying to share resources, that's probably not a good thing. The surprising thing is that in the latest survey, the standalone mode is actually used by about half of people. So I used to recommend that people don't use standalone because it's not really used in production, but apparently more and more people are using this in production. A little bit about Mesos. Mesos was actually started by Matthias before he worked on Spark. And the funny thing was that Spark was basically the first, it's kind of like a demo for Mesos. And then it became its own thing and got really big and became more important than Mesos in some ways. The thing that is unique about Mesos is that it's really designed to run all of your company's infrastructure. So you can do not just big data, but you can run all of your apps on Mesos. And this is especially true because it has great support for Docker. So you can Dockerize all of your microservices, and you can start them and run them using Marathon. The other thing is that Mesos is it's based on a C++ runtime, so it's able to run on JVM workloads. If that is important to you, you can run things like MPI. However, they are one thing that is a slight inconvenience for Mesos is that you have to run a JNI lib, but they are working around that. So they're trying to release basically for clients, a mode using HTTP REST so that you don't need to load a JNI driver. And you have the support for Mesosphere. One thing I'll be talking a little bit about later is that there's a really neat, Mesosphere has a really neat package called DCOS, where you can basically, in one command line, you can install Spark very easily. You can do a package install Spark, which is really, really awesome. How would I would phrase Mesos versus Yarn is that Mesos is a two-level resource manager. You can think of it has two levels. One is that at the top level, Mesos will offer resources. And below that sits schedulers. So you can have multiple schedulers that ask for resources. As an example, so Yarn combines resource management along with scheduling. But you can actually have a Yarn on Mesos where Yarn will delegate the resource management and take resource offers from Mesos, and Yarn will do the scheduling. And that project is called Myriad to run Yarn on Mesos. And so you can have multiple schedulers under Mesos. You can have the Yarn scheduler. You can have another scheduler for Marathon, which runs your microservices. And so that's how you can get Mesos to manage not just your big data apps, but as well as your microservices and other applications, right? And what I would basically say is that if you already have a Hadoop investment, then I think Yarn makes a lot of sense because you can upgrade your existing infrastructure. If you're starting out and you don't have a lot of investment in Hadoop, I think that you should seriously look at Mesos as a unified way to run both your applications and your big data infrastructure. There's two ways to run Mesos apps, and it's called coarse and fine-grained. What the coarse-grained mode does is very similar to standalone mode in Spark. Basically, for each worker, for each application, you have to dedicate a specific number of CPUs and memory, and it stays fixed throughout the lifetime of that application, so you can't change it. The other way to run it is fine-grained mode, and what fine-grained mode means is that you dynamically allocate executors for each task. So a Spark job is composed of many, many tasks, and so for each task, it will reallocate workers. So on one hand, it makes the resource allocation dynamic. So as you get to a stage of your job that requires more resources, it can allocate more. The downside is that you get this overhead of starting new workers for every task, and that adds latency. And you can argue that if the resources shrink, then you might also get less. So depending on your workload, one is better than the other. I would say if you're running, for example, a lot of low latency jobs, for me, I would prefer to control the amount of resources that I can guarantee. So the coarse grain would probably be a better fit. One possibility, if you run Cassandra, is Stacks Dse, because you get Cassandra and Spark and Hadoop all co-located in one package. It has HA Spark masters, but it's done through, instead of through CQPR, it's done through Cassandra's gossip. And you can use something built into DSE called CFS, which is a Cassandra-based HDFS implementation to store files. Or you can just store, more likely you would be storing your stuff in Cassandra tables. There's a lot of hosted options that are coming on board. You guys probably know about Spark on Amazon EMR, which Spark is now a first-class client, and it runs integrated with their Yarn implementation. Google Compute Engine has a Spark offering. Azure just, I think, came out with a Spark solution, which is Yarn-based also. And there's Database Cloud, and a lot more things are coming. This slide will continue to be getting up to date because I think more and more people will be offering stuff. Right. So a little bit about Mesosphere DCOS. What you see is that you can have a lot of different frameworks running on Mesos, and what Mesosphere DCOS is like a data center operating system. So it automates the deployment of different layers. For example, I can type DCOS package install Spark, and it installs Spark. And let's say that I also want to run Hadoop, and I can do DCOS package install Hadoop. So it makes setting up your different big data packages as well as other distributed packages very, very easy. And you can see them and the resource running all in one API. And it does other things for you like DNS, like the Mesos master is always available under mesos.master. And there's other things that it do. Marathon does load balancing, and so something that I would look into. I think more and more people are looking at things like this. Like one possibility you can imagine is that you can actually run your Spark applications as Marathon or Docker images, and they will automatically connect and and you would get the kind of failover because if worker dies, Marathon can restart it on another node. So it's and they run on top of Amazon as well as Google, and I think they're also supporting Azure now, but I'm not quite sure. So it's a very interesting option because on the one hand, if you run your own data center, you deploy everything yourselves. If you're running on a cloud service like EMR and Amazon, they do everything for you. So this is kind of in between. You're running on public cloud, but at the same time, you get some more control over resources and things. So a lot of stuff to get through. So configuring Spark, this is sort of really basic. You want to make sure that you build for the right version of Hadoop as well as Scala. If you're running a distribution, then you probably, you don't need to worry about this so much. So jars. Dependency conflicts are usually the worst part of deploying Spark. Spark already has Spark applications. Spark already has a lot of dependencies. So it's just a few tips. There's a lot of components to Spark. For example, like if you don't need Hive, I would definitely leave it out because Hive pulls in about like 50 different jars. You want to, in the Spark UI, there's an environment tab that has a listing of all the dependencies. So you want to make sure you check that because that's Spark's view of what the dependencies are. And you have to be aware of distribution differences, like CDH in particular tends to change, for example, the version of Akka and things that come with it. So you have to be very careful if you are building applications against, or you want to build for different distributions. Finally, there's different ways of including jars to your apps. One popular way that you can use is Spark Submit has a jars option or packages option. Packages option can automatically download dependencies from Maven. The downside to that is that it will download this at the beginning of every application run. So that also causes some latency. If you want to avoid that, you can distribute your jars yourself and use something like Spark class path. And that way, it just gets loaded at start time. Finally, I think this should be obvious, but you don't need to include. There's a whole bunch of jars that you don't need to include. If you're using streaming, you probably don't need to include the Kafka jar that's already included. In fact, if you include it, you might find more dependency conflicts to resolve. And there's a few ways to configure. There's a few configuration options that will help you with the dependencies. There is a user class path first, which is a very interesting option. What it does is it loads a different class loader that will load your jars first ahead of the ones from Spark. So if you have some conflict, this is something you can try. That this will try to load yours before it loads the one that comes with Spark. These are options, and there's some other options that you can find here. Some other options that are very interesting. I think that if you've done a lot of performance tuning, you've probably known about a lot of these. First of all, the serializer, it's very important that for all kinds of network transfers, you probably want to be using the Creo serializer instead of the built-in Java serializer. This Java serialization, as you guys probably know, it's extremely slow and takes up a lot of space. If you're doing shuffles in Spark, then the default parallelism is something that you might want to change, because if you don't specify it, it will get set to some value that you might not realize. And if you're wondering why, when you do shuffles, you hit tons of partitions, this is probably why, because the default setting is like 200 or some setting that might not make sense for your application. If you care about low latency query stuff, we'll talk about that in a little bit. You want to set the scheduler mode, the memory fraction. The slides will be available, so you guys can feel free to download and check this out later. And finally, if you're using data frames, you probably want to set the Spark SQL shuffle partitions. That controls the shuffle partitions in data frames. Finally, like if you're using standalone, there's a neat little option that you can set to prevent your temp files from filling up. This will go and clean up temporary files. A lot of people that do, like, especially if you're doing heavy shuffles in Spark, you run into this problem where Spark creates tons of temporary files, and that can easily fill up the number of. You can increase your ulimit and other things like that, but eventually you're going to end up with a lot of files that you're going to need to clean up. Finally, I would recommend that you look into using the G1 GC if you're using JDK8s. It is, especially for caching RDDs, it's supposed to be a lot more efficient in terms of cleaning up memory. Now, a few tips for running your apps in a Spark cluster. You probably want to, as I mentioned before, you should seriously consider deploying using cluster mode, and instead of running jobs on some machine, because that reduces latency for your Spark apps. If you want automatic restarts of your application in case of failure, you probably want to run your apps in supervised mode. If you're running Mesos, Marathon will do this for you. This is something that I mentioned before, but if startup latency is important for your application or job, then you might want to find a different way of deploying your jars than the packages option, which will download all your dependencies for you. It's slightly better if you just package your jars, then it doesn't have to download from the internet. It's just your jar that's being deployed. That still adds some latency. So the options are you can use packages, which downloads from Maven. You can use jars, which takes your jar and distributes it, or you can distribute it yourself ahead of time, which is what I would recommend if you really want to avoid that startup latency. Spark does have metrics for getting your application metrics out. You can configure it to write to different sinks, such as Graphite and things like that. There's some path here that you can look at the slides later. One thing but the question is, how do you get your application metrics to Spark itself? So one way of doing this is that you can use accumulators. And accumulators, in each worker, the accumulators will collect into the driver and get accumulated there. There is some glue code that you can use that will take your accumulators and feed it into Spark's metric system. Or you can roll your own. I mean, you can use, what's that package called? But there's a package that everyone uses for doing metrics, but this kind of escapes my head right now. And you might want to check if you're caching RDDs, you might want to check where they're replicated. It could be in memory, but Spark will often replicate to disk, which will take longer than if it's replicated to memory. And finally, there's a nice thread dump button in the Spark UI that you can click on and see what's going on with your application. And this is what I mentioned before. There's a class path panel to Spark that you can check out to see where it kind of tells you. The nice thing is that it tells you where your jars are coming from, if they're local, or if they came from the internet in the case of the other ones that you see the HTTP link. So that's a useful debugging resource. All right, so now we come to the second half of our talk. I'm going to talk about the Spark Job Server project and how this can help you. First of all, it's an open source project. You can find it on Spark packages, although the information might be a little bit old, but it is just under GitHub, Spark Job Server, Spark Job Server. So what is the job server? It is a REST service for Spark. You can use it to run regular Spark jobs, streaming, SQL, and the job history and configuration, the inputs are all logged to a database. One useful application for this is for low latency queries. For example, like you need to do query data frames repeatedly, but it can also be used for non-data frames. It can be used for regular Spark jobs. It can be used for different kinds of applications. Where does this fit into your stack? So a pretty typical Spark stack, let's say that you're running Spark for your batch jobs, or you have a streaming pipeline. You have Kafka going into Spark streaming into a data store. So you can imagine a Spark job server sits on top of either your streaming or your regular batch workloads. And it can be used as a front end for Spark for your internal enterprise, as well as for public cloud, because it does have HTTPS and authentication support. So why would you use it? If you want to share Spark across the enterprise, you want to give it nice, like basically a non-developer interface or a nice REST interface. Not everyone wants to download Spark and use it. People might want to have an easy to access API. You want authentication. You want easy integration. Or as I mentioned before, there's a case for low latency queries that will allow you to. That will make a lot of sense. It is used in production by companies, different companies worldwide. And as of last month, it's also integrated into DataStax Enterprise in the latest version 4.8. It's also a very active project. We have most of the code that's been contributed in the last few releases comes from outside parties. For example, there's a team in Europe, the GNIME team, that has contributed pretty big features. There are commuters on multiple continents, so we're a pretty active group. And finally, it's a platform-independent project. So it supports Spark Standalone, Mesos, Yarn. It's fine if you run Hadoop, but it's also fine if you don't run Hadoop. And we have a Docker app, so yeah. Here's an example workflow. I'm just going to skim over this because you can find details of this on the website. But basically, you integrate an API into your app, and you upload a jar to the server. Just a really quick run-through of basically there's an interface that you implement. And one difference from a regular Spark job is that there's a validate function as well as a function to run your job. Why do we have separate functions? One reason is because for an HTTP workflow, one thing that you want out of a REST resource is you want to find out very quickly if if you have valid input or not. So for HTTP, you expect when you give input to your application or to your service, you expect to get back, say, a 400 or 40 something if your input is not valid. And then if you have failures from that job, that's a different output. So the validation gives a really quick way to give feedback to say, is the input to this job good or not? And if it's not valid, then it gives back a response right away instead of taking up resources on the cluster. And the other thing that I will point out is that in the Spark job server, the concept of a job is separated from the concept of the Spark context itself. So you can run multiple jobs on a single context. And something that this allows you to do is to break up and modularize your application. So for example, let's say that I'm working with Spark data frames. I can have one job that can load and set up or update data frame tables. And I can have one that allows you to query it, and another one that allows you to run diagnostics and debugging support. So this allows you to do modular development, which I think it makes each job smaller and easier to test. Now, I'm going to skip over this a little bit. Basically, you can use standard curl if you want to. This is a work kind of example. I can give an input string, and it comes out. The result comes out in JSON, and it's what you would expect from a REST application. Here's a use case that I'll go into a little bit to run use job server low latency jobs. The goal is to have jobs that can run under a second and can answer queries on shared cached RDD data. And this is a particularly good fit because what you do is that I can start up a Spark context and I can run these jobs, and they're very low overhead because I don't need to start up the context again. The way that it works is that I start out with the Spark job server. I can do a post which creates a query context. This creates a new Spark context with workers, which are those yellow boxes. Now, I'm going to run a job to load data. This will load the data from, say, Cassandra in this case, and it will cache it into an in-memory RDD on those workers. Then I can do a query job. This query job will then query the shared RDD and return data in sub-second time frame. And then you can keep running this query, and the data gets the queries and other things get persisted to a database. Part of what this makes work is that we have a caching mechanism that is thread safe. This is actually opposed to the native Spark context API, which is actually not thread safe and relies on a number. Here, you can basically cache any kind of RDD with a string and retrieve it in another job. And you don't need to share variables. One example that you can do, another example is that you can combine streaming and Spark SQL. So you can have a Spark SQL streaming context that basically you can have a streaming job that has data coming in. This can populate a data frame. then I can actually have a query job that runs on the same context. Using this, if you're doing this, you would use a fair scheduler so that you can have multiple threads running at the same time. And this would then be able to query your streaming data out. It's a pretty powerful application. Now, some future work that we have is a true XA mode where we can do what we call a hot failover. So, for example, let's say we have a job that's running. We can have a standby one that will have data fetched regularly from checkpoints, so that we can reduce the latency of starting up another job. And if one machine fails, then we would fail over the jobs. So this is something that I think would be a pretty cool application. And this would all be done using Akka clustering on the network. And just want to thank you for all the contributions that we've gotten. We've had a very broad community. And yeah, thanks very much.
Okay, so we have time for probably just one or two questions. So, okay, here we are.
Hi.
Hi.
So you're specifying all of your configuration through the like as an environment variable. How do you specify like arguments? You say in your slide that you use the configuration of each job to pass the arguments. Say I'm developing my application and have like input path, for instance, and you have to specify all of those arguments through the I don't know what the property you use, or are you thinking to have any like command line parsing library like Scallop, where you can specify the arguments when you do this Spark submit, or in the REST job?
Okay. So I think if I understand correctly, you're asking how would you pass arguments into your job?
Yeah, because I've seen that you do the validation by reading those arguments from...
Right. So the way that you pass it is by passing a JSON. You can pass a JSON blob into your REST call, and that would become a job config object that you can parse. And so you can parse it that way. If you have input arguments, for example, you can put it as a JSON array, and then you can grab that out as an array in your application and do sc.txt file or whatever it is. That would be the standard way to do it. Yeah.
Okay, so we're just about out of time, so why don't we thank Evan?
Yeah.